So a little review here. Remember when we had equations like x squared equals 49, and we said, oh, you can take the square root of both sides. So you just take the square root of this side and take the square root of that side. And you had to put a plus or minus in it, but we were applying the square root function to both sides. And we got x equals plus or minus 7. And then we also had equations where you had the square root of x equals 5. And we said, oh, you don't want the square root there? Fine, we'll square both sides. So we said we're going to square both sides. Again, we're applying the squaring function to both sides of the equation. And we said, okay, that's okay. And we get x equals 25. And we had to check our answers, but this one checks. So, okay. That was kind of the little stipulation on that one. Well, now we're going to say if you have an equation, x equals 7, you can take the log of both sides. Log x equals log 7. Now, I used a common log. You could use a natural log, or you could use any base you wanted, and it would still be true. So you're just applying the logarithm function to both sides. Okay? All right, so that's what we're going to do in this problem. They want us to solve this equation right here. Notice the exponent is up in the variable is up in the exponent. And so I can't solve it just like it is. Now, sometimes students they try to divide both sides by 7 or something else weird, but you can't do that, okay? The x is up in that exponent spot, and we're trying to solve for x. Okay, so what we're going to do is we're going to apply the log function. I'm going to use a common log, but again, you could use a natural log if you wanted to. Now, I probably wouldn't use a different base, like log base 2, because I'm probably going to want to put it in my calculator. So I want either a common log or a natural log. And some people prefer to use the natural log, but I'm just using the common log. Now, before I finish this problem, I'm going to say, there's another way to do this, and you might be thinking, hey, why doesn't she just change it into logarithm form and get it out of exponential form? That's another way to do the problem, and I'll show you what that looks like after we do it this way. Okay, so I took the log of both sides. Well, the x is still up there in the exponent spot, but I have the property that says I can bring it down. So now I have x times log 7 equals log 43. Okay, now something I have to tell you about logarithms. When I have a logarithm and I know the base and I have a value for the argument, like in this case I have log 7, it's base 10, common log, and over here I have log 43, again it's a common log, those are just numbers. I can put them in my calculator and get a decimal approximation. They're irrational numbers because they're decimals that go on and on and on, but it's just a value, okay? So just like when I had something like, 5x equals 100, and you're dividing both sides by 5, that's what I'm going to do up here. I've got, so this is just a side note. Okay, I have x log 7 equals log 43. That, I'm just going to divide both sides by log 7, because log 7 is just a number. Okay, so x is going to equal log 43 divided by log 7. This is an exact answer. So if they want the exact answer, that's it. But I think they want a decimal approximation. Oh, find the exact answer and then approximate it to 3 decimal places. Okay, so they want this one. That's the exact answer. And now we're going to get a decimal approximation. Now we did this on our calculators before, so let me turn on my calculator. I'm going to go log, and then it opens that parenthesis, right? So I got to go 43, close the parenthesis, then hit the division, log 7, close the parenthesis, and I get 1.93, oh, it's going to round up, 3. Okay, so that would be the decimal approximation to 3 decimal places. And they want both of those answers, the exact answer and then the decimal approximation. Okay, I said I would show you the other way to do this. So you have 7x equals 43. If I change it to a logarithm equation is log base 7 of 43 equals x. Well, now I can use the change of base. So log 43 over log 7. And again, I used a common log, but you could use a natural log. And then that's what we had on the other way of doing it. Okay, so we get the same answer.